friends, in this video I am going to solve some examples on student t distribution with simple mean or single mean. A certain stimulus administered to each of the 12 patients resulted in the following changes in the blood pressure: 5, 2, 8, -1, 3, 0, 6, -2, 1, 5, 0, 4 in approximate units, whatever that unit may be. Okay, it can be concluded that on the whole of the stimulus will change the blood pressure. After giving the blood pressure, after giving a one injection or one stimulus, there will be a little bit change in their blood pressures they have observed with the 12 patients. Can it be concluded that after giving with a 5% level of significance, whether it is going to change in the blood pressure or not? Going to check. For this, let me take the null hypothesis first. To solve this, H0 is the stimulus will not change the blood pressure. The stimulus will not change the blood pressure. That is nothing but mean of this is population is equal to 0 only. There will be no change in mean. That mean will remain the same. Then what is the alternate hypothesis? H1, the stimulus will change. Stimulus will change the blood pressure. Means that is mu is not equal to 0. Therefore, it is a two-tailed test. Two-tailed test will happen here. Now, I have to find the test statistic. Test statistic is nothing but t is equal to, or modulus of t is equal to modulus of x bar minus mu divided by square root of s square divided by n. I have to calculate this. Then how to calculate x bar here? X bar is nothing but the sample mean x bar, that is given by sum of all x values divided by n, size of the sum of all the given things. I have to add up 5 plus 2 plus 8 minus 1 plus 3 0 plus 6 minus 2 1 5. Addition will give you, sum of all these values will give you 31 divided by sample size that on 12 patients they have done, that is divided by 12. It will give you 2.5833 mean. Then second one, mu, we have assumed it is not equal to 0, and s square, sample variance s square is equal to 1 divided by n minus 1 into bracket sum of xi squares minus 1 by n into sum of xi the square. Substitute all these things. 1 divided by n minus 1, that is 11, into sum of xi squares, squaring and adding them, 5 square plus 2 square plus 8 square plus minus 1 square plus 3 square, like that, all adding all of them, we are going to get it as 185 minus 1 divided by 12 into sum of x I already 31 31 square. Simplify this using calculator and all those things. We are going to get it as 9.5378 is nothing but your s square. Okay, this is x bar and this is your s square. Therefore, s is equal to square root of this is nothing but 3.08833 is the s value. Substitute all these things in the test statistic t. Therefore, modulus of t is equal to modulus of x bar 2.5833 minus 0 divided by square root of s square 9.5378 divided by 12, and use the calculator to simplify this. I am going to get it as 2.8976. Okay, therefore t is equal to modulus of this 2.8976. Go to compare, this is calculated value. This one we have to compare with the table value with the degree of freedom 11. In the problem they have given with 5% level of t value, table value with the degree of freedom 11 is 2.201, which is nothing but the for 5% level with the degree of freedom 11. Here it is less, it is greater than this, correct? 2.89 is greater than, therefore hence we conclude that H0 is rejected. Therefore conclusion is H0 is rejected. That is, rejection of H0 means what? There will be a change in the, there will be a change in the blood pressure after stimulus. Okay, like this. Another example I am going to solve here. Student t distribution here. Okay, a random sample of size 16 is less than 30, therefore it is a small samples, has a 53 as a mean. The sum of the squares of the deviation from mean is 135. That is, sum of the squares of the deviation. Can this sample be regarded as taken from the population having mean equal to 56? Obtain 95%, 99% confidence limits of the mean of the population. First I have to check whether it is sample is taken from the mean with population 56 or not. Okay, then I have to find out the 95%, 99% confidence limits of the mean. Okay, now first here given, what they are given things, given data, sample size n is equal to 16, then sample mean x bar equal to 53, and sum of the squares of the deviation from mean means sum of deviation means x minus x bar, deviation from mean x minus x bar, squares of it equal to the given, correct? Sum of the squares of the deviation x minus x bar square summation equal to 135 they are given. Okay, as well as population mean mu is equal to 56 they have given. Using them, I have to check whether the sample is drawn from the population or not. Okay, null hypothesis first. H naught. There is no significant difference between the samples. There is no significant difference between the sample mean and population mean. Population mean mu is equal to 56. Therefore, alternate hypothesis is there is a significant difference, that is mu is not equal to 56. Okay, that is a two-tailed test again. Therefore, test statistic modulus of t is equal to modulus of x bar minus mu divided by square root of s square divided by n. Okay, now x bar they are given, mu they are given. What about s square? S square, we have two formula to find out that. That is 1 divided by n minus 1 into bracket summation of xi squares minus 1 divided by n into summation of xi's squares, or 1 divided by n minus 1 into summation of xi minus x bar its square, that is deviation squares. Therefore 1 divided by 15, this is equal to, they are given as 135, and it comes out to be 9. Okay, s square is equal to 9. Therefore, substituting here, modulus of t is equal to x bar is 53 minus 56 divided by square root of 9 divided by 16, and it is minus 3 divided by 3 by 4. This is going to cancel, which is equal to, reciprocate it, you will get a minus modulus of 4. Therefore, t is equal to 4. This is a calculated value of t equal to 4. This one we have to compare with this one for 15 degree of freedom table value. Okay, which is 2.131, or here degree of freedom is equal to n minus 1, that is 15. For 5% level, we can use the table also. If it is not given, from the table we can find out. The table is for degree of freedom 15 in under T distribution, 15 degree of freedom, and column 0 along 0.025 for 5%, because it is a two-tailed test. For that, this value we can have. .131. Go to compare. This is the table value. Okay. Therefore, 2.131 is my table value. That is T.0 for 5% level of significance with a degree of freedom 15. Therefore, this is greater than 2 points. Therefore, H naught is rejected here. H naught is rejected. That is the sample is with mean 53 is not drawn from the population, from the population with mean mu is equal to 56. Okay, using this I have to find out then what is the population interval, for the confidence interval I have to calculate here. Now to find the confidence limits, first for 95% level I have to find out. That is given by mu is equal to x bar plus or minus t alpha into s divided by root n. Okay, therefore t alpha is for 95%, x bar value is 53 plus or minus t alpha value for 95%, just now I have calculated, it is 2.131 into s square I have calculated, or s also equal to 3 divided by square root of 16. Therefore 53 minus 2.131 into 3 divided by square root of 16, comma 53 plus 2.131 into 3 divided by root 16. These two have to calculate. Using the calculator you can find out this value. It comes out to be 51.4018, comma 54.5952. This is the confidence interval for 95%, because this I have chosen it as a 95%. T 0.05 with the 15 degree of freedom is 2.131. Okay, like that for 99% confidence limit, mu must be equal to 53 plus or minus, for 99% level of confidence, that value is for 99% for 0.001 table I have to check. Its value is, once again, for 99% confidence limit, for 15 degree of freedom, and for 1%, that is 0.05, half of the 1% is 0.05. that column I have to check, because it is a two-tailed test. Therefore 2.947 I have to take. Here T alpha, that is a T of 0.01 for 15 degree of freedom is 2.947 I have to use. Therefore it is 2.947 into 3 by 4, that is a square root of 16. Therefore 53 minus 2.947 into 3 by 4, comma 53 plus 2.947 into 3 by 4. This I have to calculate. This interval is nothing but 50.7898 and 55.2102 is my confidence interval for 99%, and this is the confidence interval for 95%. Okay, like this. Some more examples I am solving here. Okay friends, another example on student T distribution I am going to solve here. That is, 10 individuals are chosen at random from a population and their heights in inches are found to be 63, 66, 67, 68, 69, 70, 71, 71. Test the hypothesis that mean height of the universe is nothing but again population, is 66 inches. Okay. Now given data Sample they are given. Sample size or sample they are given. Sample size n is equal to they are given. It is a 10. And sample also they are given. Sample is 63, 63, 66, 67, 68, 69, 70, 70, 71, 71. Okay. And what else they are given? Population mean they are given. Population mean mu is equal to they are given. Population mean mu is equal to 66 they are given. Using this, I have to check whether that population mean mu is equal to 66 or not for the sample. Okay. Null hypothesis H naught I will consider first. Okay. Sample mean mu also is equal to x bar is equal to 66. I have to prove. Okay, I am assuming first. Then H naught, that is mu is not equal to 66. Okay. Then test statistic. And again here you can just observe here, it is a two-tailed test. Okay. Modulus of t is equal to x bar minus mu divided by square root of s square divided by n. X bar equal to, I have to calculate now. X bar equal to sum of all xi's divided by n. Sum of all these xi's divided by n. That is 678 divided by 10, which is comes out to be 67.8. Okay. Then s square I have to calculate. S square is equal to 1 divided by n minus 1 into summation of x minus xi minus x bar the square. I have to calculate. Okay. That comes out to be 9.067. Okay. All these calculations and s is equal to, it comes out to be 3.011. All these calculations can be done in calculator directly. Okay. How it is? Let me explain step by step here. First of all, shift the mode of the calculator to stat mode for operating this. Okay. Then AC button. Then operate shift 1 so that type will get. From that one variable I will select. I will enter the given data. That given data is 63, 63, 66, 67, 68, 69, 70, 70, 71, 71. Therefore, total 10 data I have entered. 11th one will remain the blank. Then put AC button. Then it is stored in the memory. Then to find out x bar, shift 1. Shift 1. You will get variance from the option number 4. Then to find out x bar, option number 2 is, we will get 67.8 directly. Like that, how to find out this s square and s directly? Again, AC button, shift 1, in that variance option number 4 and sx we are given 4. You will get 3.011 as a directly yes. No calculation part is required. Okay. Directly also you can write sx. Now use these things in the calculator. Therefore, modulus of t is equal to x bar is 67.8 minus mu is 66 divided by square root of outside the square root of s will be yes 3.011 divided by root 10. And simplify this, calculate using the calculator. I am going to get it as a 1.89 modulus value. Therefore, t calc value I am going to get it as a 1.89, whereas the table value they have given it as in the problem itself they have given, or you can use the table also. Okay, its value is 2.262 equal to table value for 0.05% of the degree of freedom 9. Therefore, it is less than the table value. Therefore, here null hypothesis is accepted. Therefore, H0 is accepted for 5% level of significance. Therefore, the mean of the universe, mean height of the universe is 66 inches. Okay, like this. Next I am going to solve examples of a chi-square. Okay, goodness of fit. Thank you friends. Please subscribe my channel and give the comments. Also don't forget to hit the like button. Thank you very much.